The L function can be obtained by the subordinate zeta function of the binomial theorem of the zeta function, and the L function can be inverted again by the functional equation. The difference between the subordinate zeta functions 3, 1 and 3, 2 is the L function of mod 3, and if inverted by the functional equation, the L function can be obtained by the zeta function of the negative domain. When the binomial theorem of the zeta function is inverted, the gamma functions disappear, and only the zeta function and trigonometric function for the L function remain. Therefore, it becomes a simpler form for the L function, making the interpretation easier. In addition, since most of the zeta functions of the first term are eliminated, the L function of the critical strip is expressed only by the zeta function of the negative domain. The purple L function of mod 3 is calculated with 2 alternating sum of the zeta function up to 70 terms, and shows an error of more than 10 decimal places at s equals 1/2. The error is 6 decimal places up to 30 of the imaginary part A, but when the imaginary part exceeds 30, the error of the L function increases. Since the L function is the sum and difference of the subordinate zeta functions, the nontrivial zeros of the subordinate zeta function also exist on the critical line, and this can be called the universal Riemann hypothesis. If GeoGebra supports the gamma function of complex numbers, the nontrivial zeros of the subordinate zeta function can be shown with a graphing calculator, but the nontrivial zero of the L function can still be shown by inversion of the L function. Therefore, in order to prove the Riemann hypothesis, not only the generalized Riemann hypothesis, but also the universal Riemann hypothesis must be proven, and it is not known whether it is a provable problem.